so it slides under the continental crust. And when it does that, you have this development. Remember I said we had trenches? This is how they develop at this point in time. Now what happens is then we have this continually pushing. Right now our continent, North America, is moving to the west at approximately 2.5 to 3 inches per year. It's relatively fast. And they say it's about the way your finger, about the rate of growth of a fingernail or a toenail. I don't know about you, but my toenails grow faster than my fingernails. But somewhere, depending on where you are in the world, it'll move anywhere from 1.5 to 4 or 5 inches per year. Lateral movement. So in another 50 million years, we will have overridden and crunched up Japan, and we would be attached to China and Russia. And then it would start all over again. It would split. We call that a Wilson cycle. No problem. That's not has nothing to do with an earthquake. But this area here is the part that we're most interested in for now. At a convergent boundary. Now this is the type of system we're talking about. I said plates. That's what we call tectonic plate motion. And this is the major plates around the world. There's this upper 15 to 20, 25 mile thick layer broken up into a number of different units, all of which are moving. For example, this is moving this way. This is moving to the west. This is moving to the east. This is moving to the east. This is moving north, that way. This is India. I'll show you what happens. We have an example pretty soon when they actually collide. Now these areas too then are actually points of friction, places where things are moving around and they're broken up. They're cracking things up, moving them down, tilting them, making them sink. And that area is represented commonly by what we call seismic activity. Seismic activity is a term we apply to any sort of earthquake motion or movement. There are also areas where we have lots of volcanoes, because you're cracking the Earth's surface, you're making big holes in it, and molten material comes up through it. I'll show you how that works in a moment with a little movie, if it works. These areas here, the red dots, they represent points where earthquakes are most commonly occurring. Those are regions where as these plates move then, they're probably rubbing against each other. And it's just sort of like if you have a car, two cars come close together and they rub together, well, they have friction, and you will have all rending motions. You'll start tearing things apart that way. That's what happens to the Earth. And that's where earthquakes come from, the major parts of it. Okay? In this particular area, we've all probably, most of you have heard maybe something about the San Andreas Fault. And they say California is going to split off and drop in the ocean someday. Well, it's going to split off, and it's going to be moving north way and be part of Alaska. It's a different thing entirely. But anyway, this is the type of situation we're talking about. Pacific plate here, this is the plate here, African plate coming like this. And we have, as these materials move, they begin to split up. This is the Pangea. This is what it looked like approximately 225, 230 million years ago. Okay? Then it began to split. Broke up. Here's North America, South America, Africa. And as time went on, they kept splitting apart, moving further and further apart until we get to today. I'll show you another picture. It's a little better than one pretty soon. But all the time it's moving like this, you have this bottom surfaces of these plates are encountering each other, and they're hitting and just sliding. And like most things that slide, you don't, unless you have a completely smooth surface, it'll slide and stop for a second. And then you'll keep the pressure on it, it'll break. Like opening a can for your calcium or the top of a jar. Those burger jars have that problem every once in a while. You have to keep twisting, you build up potential energies, and finally bust it open. And you spill it all over yourself the way I do. But anyway, this is what happens then. And you continually fill up this area in here, as it's broken, with water. As the magma, the molten rock wells up, and as it opens up, the water flows in from everywhere else. And this is basically the idea again in a different form. So this is a better looking thing. What we have here is the late Jurassic, about 150 million years ago. We've already broken off from here. We're breaking off from here. South America hasn't broken off yet. Now we go about another 50, 60 million years ahead, sea now. Another 69 million years ago, this is about 4 million years before the dinosaur died. That's in here. And there's nothing together here. Here's North and South America. They're separate. There is no Central America. But this is the type of thing that's happening all the time, continuing to move until we get to the modern day situation where we have the present day configuration of the continents and the oceans. Am I going too fast? Okay. How many people are sleeping? Come on. It'll work. Basically what happens as you begin splitting these things apart, I'll show you how all this fits in a minute. As you begin splitting the continental masses apart, and you start spreading, and you take portions of these and they break up, and you have long, linear, what we call rift valleys. And the rift valley, like these are the west coast of Africa. This is Lake Kenya, Lake Victoria, Lake Tanganyika. All of these represent areas where this portion of Africa is being split off. Madagascar here is a place where it happened probably 10 million years ago. It was also part of the African mainland. Let's see, you see how this fits here? That's where it used to fit. It breaks off. If you go to California now, there are channel islands called Santa Cruz, Santa Maria, Santa Catalina. All used to be a part of the Pacific coast. Except they weren't part of our coast. They were part of Baja California. They have come loose and moved northward along the plate as it moved, as the San Andreas Fault moved. It developed in those times. Now in our country, in North America, this same thing happened. And it happened right along this area here. Right here. So as you move into like areas like New Jersey, New Hampshire, Vermont, up to Nova Scotia, down into North and South Carolina, they're buried now in that area, Georgia, then the same thing here happened. It began to split with these huge, deep valleys. And they were filled with volcanics, deep enough, and they actually had volcanoes come up when it hit, when it started, and filled them up now. You can now see the Palisades in New York are remnants, are parts of those old volcanic flows associated with this phenomenon. You can take a boat ride up the Palisades along the Hudson River, and that's where they came from. The old volcanoes that came up in those valleys. Here is where we are. You'll see that there's a strange thing here. This is the Gulf of Mexico, or where the Gulf of Mexico was. 65 million years ago, the Gulf of Mexico had beaches. Orange Beach, Alabama, was actually at Paducah, Kentucky. And that's basically what happened. Here, it began to split, but it didn't quite split all the way. In other words, it's sort of like taking a green twig and you break it, but it doesn't come apart. It splits. And that is what this zone that we have a problem with. The New Madrid fault system is based on. That's where it came from. Okay? So these areas then, which we call subduction zones, right in here, where the oceanic plates are underwriting, going under the continental plates, we call subduction zones. They have volcanoes and are noted for earthquakes. Now this is what I hope this works. It doesn't. Explain all the variables. Okay, Bob?
That's okay.
All right. Just take a couple seconds. One, I'm going to show you a little movie of how this system actually works. This is based on the western U.S. and California. Okay? Okay, let's go. Now, what we have is this area with a subduction zone so far. And this area here is where the subduction is taking place. Basically, in this case, the North American continental crust is moving over the Pacific plate. Remember, it's lighter. It's much lighter rock than the oceanic rock. And as it does, and you're having this motion through here. Now, two things watch. This area, and watch this stuff. But as you get this rock deeper and deeper into the earth, it gets hotter and hotter and begins to melt. As it melts, it turns liquid. And what happens when you have something that becomes liquid? It becomes, well, your pipes, when they freeze, what happens to your pipes? Why does that happen? Because the water expands. In the same distance, you have a solid that turns to a liquid. The liquid is